Alright, here's a famous lighthouse problem of 2002. A ship was traveling due west toward Lighthouse Rock at a speed of 15 kilometers per hour. Toward it? So due west. Say, oh look, we got a cute little compass right here, northeast, south, and west. So this ship right here, ship A, is traveling towards this lighthouse. Ship B is traveling due north away from the Lighthouse Rock at a speed of 10 kilometers per hour. Let X be the distance between ship A and the lighthouse. Blah blah blah. This is X right here. Oh, let's label it. They didn't label it. No wait. No, it's right here. There's X, and then there's Y. It defines it right here. And let X be the distance between ship A and the lighthouse at the rock time T, and let Y be the distance between ship B and the lighthouse at time T. Shown in the figure above. Actually, it's right here because this is an SG. All right, A. Find the distance in kilometers between ship A and ship B when X equals 4 and Y equals 3. So X equals 4, Y equals 3. We got to find the distance between the two. And if this image isn't a clue enough, then why are you sitting in here? All right, so we need A squared plus B squared equals C squared, but I'm going to do X squared plus Y squared equals C squared. And X at this time is 4, so I'm going to put 4 right there, and then Y at this time is 3, so put 3, and I'm trying to find C. So we got 16 plus 9 equals C squared, so we got a 25 equals C squared, which means C equals, well, plus or minus 5, but minus 5 doesn't make sense when we're talking about distance. So this is our distance. Let's make sure we have our label 5 kilometers. Alright, so that's the answer to A. Let's attack B. B says find the rate of change. Hey, a rate of change. You know what that means? That means we're going to find something with a dt on the bottom of it. So something, d something over dt. So derivative of something with respect to time. What are we going to take the derivative of? Let's see. We're going to find the rate of change in kilometers per hour of the distance between the two ships when x equals 4 and y equals 3. So the distance between two ships is C right now. That's what I chose to label it as. So that means this is going to be the derivative of C. So we're trying to find dc over dt. So how are we going to get a dc over dt? Well, let's take our formula that we had earlier. Let's see, we got this guy. We had x squared plus y squared equals c squared. Now this is very important. Whenever you're doing a rate of change problem, you do not substitute in numbers for variables that change. Now, is x changing right now? Yes, the ship is going towards the lighthouse. Right? Is y changing right now? Yes, the ship is moving away from the lighthouse. I think it says it all right here. Let's see. A ship A is traveling west toward the lighthouse at a speed of 15 kilometers per hour. That's a rate right there. And ship B is traveling due north away from the lighthouse at a speed of 10 kilometers per hour. Okay, so I just want, right now my only goal is to get a dc over dt. And so I find an equation that has a c in it, and then I take the derivative of that equation implicitly with respect to t. So here's the equation I got, and I'm going to take the derivative of this with respect to t. So if I take the derivative of x squared, first I just do derivative like regular, and I get 2x. But then I have to multiply this by dx over dt, because we are taking the derivative with respect to t, not x. And so the next one is going to be 2y dy over dt, same thing as the x. The one after that is going to be 2c dc over dt. It looks like we can divide everything by 2 to simplify this. Let's do that. By 2, by 2, by 2. Okay, cool. All right, next. Do we have a number for every single variable so that we can find dc over dt? We got a lot of variables. We have one right here, 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 and we have one right here. And this is the one we're trying to find. So do we have those 5 numbers? Let's find out. Let's see. It says, oops, did I do anything? Go back, cross those 2's out. Okay. Let's see, the x. Do we have the x? Yes, it says right here that x equals 4. So I'm going to plug in a 4 right here. And then, what about dx over dt? Do we know the rate at which the x is changing? It says ship A is traveling due west toward the Lighthouse Rock at a speed of 15 kilometers per hour. Now, this is where things get a little tricky. Do I just put 15 right here? why do I put negative 15? Okay, is x is the distance of x increasing or is it decreasing? It is decreasing, so that's why I'm going to put negative 15. That is my rate right now at which the x is changing. All right, now let's do the y. Okay, y, what is y? Y is 3, so I put 3 in, and then I have dy over dt. And what about this rate right here? This dy over dt. dy over dt is changing at a positive rate because dy over dt is going that way, which means y is increasing. So what is that rate? Let's see. Is traveling so 10. Okay, yes. So I put 10 right here equals c. Do I know what c is when x is 4 and y is 3? Yes, we just did that in letter A. So I'm going to put 5 right there. And now I can get dc over dt alone. I'll be able to solve this problem. Okay, so this is going to be, what is that, negative 60? No, not 16, negative 6d plus 30 equals 5 dc dt. Okay. Let's see, that's going to be a negative 60 equals 5 dc dt. So what does dc dt equal? dc over dt equals negative 30 kilometers per, what was it, second? Oh, hour. Did I not add right? All right.
Negative 30 equals 5.
Oh, okay, yeah. Good looking out, guys. All right, so this is supposed to be a negative 30, and then I'm supposed to divide that by 5. So my answer is not 30. What was it? It's negative 6. All right. All right, our next question is asking about theta. It wants to know the rate of change of theta. So now we're not looking for dc over dt anymore. We're looking for a new problem. We're looking for d theta over dt. Okay, so is there, oh look, they even put a theta in there. Is there a trigonometric function that you know of that we can use? Actually, we can use any trigonometric function, can't we? We can use, let's see, ABC, no, ABC, okay, C. We can use tangent. We can say tangent of theta equals, what is that, 3 over 4? What's the opposite side of theta? Opposite is right here. Y is 3. Okay, yeah, 3 over 4. Or we can use sine of theta, which equals, that would be opposite 3 over 5. Or we can use cosine of theta, which equals 4 over 5. Now, which one would be the safest to use? It would be tangent. And the reason why tangent would be the safest to use is because 5 is a number that we found. Now, I know that our number 5 is right, but 5 is a number we found, and we don't want to. What if we got the wrong number there? You know, so let's use tangent. So, all right, now I'm about to take the derivative of this because I want to get a d theta over dt, but I'm about to make a big mistake. Do you guys know what mistake I just made? Nobody? Come on. All right, I already plugged in the 3 and the 4. I shouldn't do that. Why? Because those numbers are currently changing, and I don't want to plug those in and then do my derivative because then we won't get an accurate equation. All right, so then we have, see, that's x. No, is that x? No, it's y. Y over x. All right, so let's take the derivative of both sides with respect to t. All right, first we got tangent. The derivative of tangent is secant squared theta, but then I'm going to multiply that by d theta over dt. Because you do the derivative of the outside and then the derivative of the inside. The next one, this is going to have to, we're going to have to use the quotient rule. You could move the x up and use the product rule. You would have a negative exponent, but I'm going to just use the quotient rule. So let's take the derivative of the top first. Derivative of the top is just 1, and then I have to multiply it by dy over dt, and then I multiply it by x, minus the derivative of the bottom, which is 1, and I multiply that by dx over dt, and then I multiply it by y, all divided by x squared. All right, let's find. Now we're trying to find secant squared theta. I'm sorry, we're trying to find d theta over dt. So that means we need to plug in a theta We need to plug in one of those, one of those, one of those, one of those, and one of those. Do we know what theta is at this point when y is 3 and x is 4? Oh, stinker face. We don't know what theta is. And we have to know what theta in order to find the d theta over dt. We know what x is, we know what dy over dt is, we know what dx and dt. We know all of these variables right here, but we do not know what theta is. Oh, we're going to have to press pause on this problem and go over here to try to find d theta over dt. Oh, let's use our little triangle right here. Okay, so we have our triangle right here. This side right here is, what is the x? The x is 4. And let's see, this side right here, this is 3, and we know this is 5. Okay, how are we going to find that theta right there? Now, I need a theta, and so in order to plug in a theta, I need to know what theta is. And so I'm going to set up an equation, and we can set up a lot of different types of equations. We can use sine, cosine, tangent, cosecant, secant, or cotangent. I'm going to use secant so that this secant will cancel out with this stuff. But there is another way to do this. My way is not the only way. So if I said secant theta equals, you'll remember that secant is the reciprocal of cosine. What would cosine be of this theta right here? It would be adjacent over a hypotenuse, and so you would have 4 over 5. So what would secant be? Secant would be 5 over 4. Okay, everybody still with me? Yeah? Maybe? Yes? Okay. Now, how do I get theta alone? I would do secant inverse of both sides, so I get theta equals secant inverse of 5 over 4. And I'm not going to simplify anything. I'm going to leave it there. Okay, I'm assuming that I do not have access to a calculator or anything like that, so I did this because look what theta equals. Theta equals the secant inverse. And when I plug a secant inverse into that, they're just going to cancel each other out. So, let's go. Plug that theta in. So we're going to have, oh man, I'm running out of space. Hold on, let me make some more space. Okay, so I have a d theta over dt, and then I have a secant, and inside a secant, I'm going to plug in secant inverse of 5 over 4, and then that secant is going to get squared. I just took this squared, and I made the squared go outside, so I don't have to deal with him right now. I can kind of see clearly what's going on. The rain is gone. Never mind. Okay, dy over dt. What is that? We had it earlier. That's this guy right now. How is the y changing? Is it changing in a positive way or a negative way? Positive way. So dy over dt is positive 10, right? It's the rate at which the b is moving away. So I got 10 times x. My x right now is 4. Then I got minus. I have a dx over dt. dx is right here. That was a negative 15. Negative 15. And then times y, which is 3, divided by x squared. X is 4, so x squared would be 16. All right, that side's cleaning up nicely. Now, check this out. Ping, ping, yay. And then we just have to square it. Okay, so what is 5 over 4 squared? That's going to be, see, we got d theta over dt. We got 25 over 16. Now on the other side, there's some more simplifying to do. This is going to be 40, and this right here is going to be, let's see, slash and dash. We got a 15 times 3, that's 45. So we have a 40 plus 45, which is going to be 85 over 16. I multiply both sides by the reciprocal of this guy, and that's going to get rid of him over here, and over here I'm going to go 16 over 25. The 16s cancel out, and I get 85 over 25. And that is all I'm going to do. I'm going to leave my answer like this, even though we can simplify it. And the reason why I want to leave it like that is because sometimes if you simplify and make a mistake, you get marked down. But let's do it anyways. Divide the top by 5, that's going to be 17. Divide the bottom by 5, it's 5. And we could make this into a mixed number that would be 3 and, what is it, 2/5. Don't forget your label. It's radians. Oh, per what? Per. Okay, come on. Okay, per hour. Is our T in hours right now? Yeah, it is.